Hello everyone. With just a few days left till the IGCSE maths exams of October-November 2024, I'd like to go through arguably one of the most difficult problems given in an exam. Because as you can see here, this is a stunning 11 marks, this one question. So I just wanted to go through this to make sure that you're all ready and confident for the exams coming up, especially the paper 4. So yeah, let's start. So here, if we just take a skim through, we should be familiar with trigger words. These are words which remind us of certain topics. As you can see here, we've got a lot of times given to us. And then we have this speeds. So we should be thinking of speed, distance, time. So immediately before starting, remind yourself of the speed, distance, time triangle. Speed, distance, time. Because this question, as you can see, find the overall average speed, will need assistance from this triangle. So now let's begin to read. So Brad traveled from his home in New York to Chamonix. He left his home at 4:30 p.m. and to reach the airport in New York, it took 55 minutes and had an average speed of 18 kilometers per hour. So what we should do with these type of problems is have two separate, a table with two separate columns. One with, since we're wanting to, in the end, work out the average speed, we should have one column dedicated to distance, total distance traveled, and total time. And we should make note of these as we go along. So in the first question, we see that the journey took 55 minutes and had an average speed of 18 kilometers per hour. So therefore, the distance traveled here, we've got the speed here, this is the speed, and this is the time. So from the speed, distance, time triangle, we know that distance is equal to speed multiplied by time. So therefore, the distance traveled here is, now we have to be careful with this because the time here given to us is in minutes, whereas the speed is given to us in kilometers per hour. So we must convert the 55 minutes to hours. So 55 minutes is equal to, all you have to do to convert is 55 divided by 60. That's the number of minutes in an hour. So that's equal to 55 divided by 60 is equal to 11 over 12 hours. So to go to the airport, it took him 11 over 12 hours. So now we can calculate the distance, which is the time, 11 over 12, multiplied by the speed, which is 18. So the total, firstly, from the first statement that we're given, the distance traveled is 11 over 12 multiplied by the speed of 18 kilometers per hour. And after we put this into our calculator, we get a distance of 16.5 kilometers. So 16.5 kilometers here. So already to go to the airport, he took 16.5 kilometers, the journey. So that's the first statement done. Now the second statement, we've got, now he's traveling to Geneva departing from New York. And the flight path can be taken as an arc of a circle of radius 6,400 kilometers with a sector angle of 55.5 degrees. Okay, so let's just visualize this with a quick little diagram. So this is like the arc. We're interested in this arc around right here. So it says that the radius of this is 6,400 kilometers, and the sector angle is 55.5 degrees. And this highlighted area right here is the flight path So for example, this is New York here, this point right here, and this point is Geneva. So what we're going to do is calculate the distance between these two places. So how we do that is, we know that if this was a full circle, the perimeter of the full circle would be 2 pi r, right? But here we only have a sector with angle 55.5 degrees. So therefore, as a fraction of the entire perimeter, it's 55.5 over 360 multiplied by 2 pi r. Because this New York to Geneva is only a fraction of the entire perimeter. So therefore, the distance between New York and Geneva is 55.5 divided by 360, which is the total number of degrees in a circle, multiplied by 2 pi r. R is 6,400 kilometers. And now after putting this into your calculator, you should be getting an answer of, if you round it up, it should be giving you an answer of 6,200, because you get something like 6,199.40. And if you round this to 3 significant figures, you get 6,200 kilometers. So that's the difference, the distance between New York and Geneva, 6,200 kilometers. So now from the second statement, we know that there is a further distance traveled of 6,200 kilometers. And now for the final statement. Now he is traveling. Okay, again we're given the speed and the time. So it's 1 hour 36 minutes. But we need to convert this to a decimal to be able to work with multiplying. So 36, the way we do this is 36 minutes. To convert that to hours, we do the same thing that we did up here. So 36 divided by 60, so 36 minutes is equal to 36 divided by 60 hours, which is equal to 0.6 hours. So 36 minutes is 0.6 hours, and 1 hour, we just simply add that on to 0.6. So 1 hour 36 minutes is equal to 1.6 hours. Okay, so the bus journey took 1.6 hours, and the average speed he traveled at was 65 kilometers per hour. So the same thing, from this triangle, we get that distance is equal to speed multiplied by time. So therefore, from the final statement, number 3, we see that the distance is equal to speed times time, and the speed is 65 kilometers per hour, and the time taken was 1.6 hours. So 65 multiplied by 1.6. And that gives you an answer of 104 kilometers. Okay, so now we have all the distances that he has traveled. So now what we do is we sum these all. So 16.5 plus 6,200 plus 104. And that gives you a total distance traveled. Total distance traveled as 6,320.5 kilometers. Okay, so now we've got the distance. And now all we have to do to calculate the average speed is to calculate the time taken. The overall time taken. So what we can do is simply find the end time when his journey ended, the time his journey ended. And you can see that his journey ended 1 hour 36 minutes past 1 o'clock here, 1 p.m. his journey ended 1 hour 36 minutes past 1 p.m. the next day. So he started on day 1 at 4:30 p.m. and he ended the next day at 1 hour 36 minutes past 1 p.m., which gives us a time of 36 minutes past 2 p.m. So this is when his journey ended. However, we need to see, this is an important statement right here. The local time in Geneva is 6 hours ahead of the local time in New York. And we also need to note that the local time where his journey ended is the same as the local time in Geneva. Hence, the local time here is 6 hours ahead of New York. So therefore, to calculate the total time that he has actually traveled, it's not just the time between 4:30 p.m. on the first day and 2:36 p.m. on the next day. We have to subtract 6 hours from this so that we calculate we're assuming that we need to assume that the journey took place with New York local time. We have to stick to one time zone so that we don't skew the time data. So we need to stick with one time zone. So we could either stick with the Geneva time zone, which is 6 hours ahead of New York, or we could stick with the time zone of just New York City. So I'll show you both ways, in fact. So if we need to keep the time zones, we always remember to always keep the time zones constant when working with speed distance time problems. They'll always try to trick you out by giving different time zones. So if we stick with the New York City time zone, the way we do this is we subtract 6 hours from 2:36 p.m. the next day, which gives us 8:36 a.m. on day 2. So this is his end, and his start is, as we know already, it's 4:30 the previous day. So therefore, the total time taken, the change in time, is equal to the end time minus the start time. But remember that this end time is the next day. So the way I would do this is calculate the time from the start, 4:30 p.m. to 0000, which is exactly the time in between both days. So if we calculate the time from 12 right here to 4:30, that would take him 7 hours 30 minutes. Sorry, not 7 hours 30. Oh, sorry, it is 7 hours 30. Yes, it is 7 hours 30. So between 4:30 p.m. on day 1 to 12 midnight, it would be 7 hours 30 minutes. So 7 hours 30 minutes. But now we have to add on the 8 hours and 36 minutes that runs over to the next day. So we add 8 hours 36 minutes. And therefore the total time taken, if we add these two together, we get 16 hours and 6 minutes. If you add these two together, because you have an extra 6 minutes over here. 7 hours 30 plus 8 hours 30 is 16 hours. But then we've got the extra 6 minutes right here. So therefore the total is 16 hours and 6 minutes. So 16 hours and 6 minutes. So therefore, we find that that is the time taken for his entire journey. We can also do the exact same thing with the Geneva time zone or the Chamonix time zone, since they both are the same. So there, we know that the end time is 2:36 p.m. on day 2. That's the same time zone as Geneva. So the end time is 14:36. But the start time, now we need to add on 6 hours to the time that he began in New York to make sure both times are in the constant time zone. So if he started at 16:30 and you add 6 hours to that, it would just be 22:30. So 10:30 p.m. on the first day. So if you put that in here, 22:30. And now if you do the exact same thing, from 22:30 to midnight, it would be 1 hour 30 minutes. And then you add on this extra 14 hours 36 minutes onto the next day. So plus 14 hours 36 minutes. And now if you have 1 hour 30 plus 14 hours 30, that would give you 16 hours. But remember that you have this extra 6 minutes right here. So 16 hours and 6 minutes. And as you can see, we've got the exact same time for both cases. All we've done is just made sure that the time zone is constant. So therefore, now we can fill this information in. We know that the total time taken for his journey is 16 hours, 6 minutes. Therefore, his overall speed is equal to total distance divided by total time. And remember, we need to convert this to a decimal to be able to work. So 6 minutes as 6 minutes in hours is 6 divided by 60. The same that we've done here to calculate from minutes to hours, converting from minutes to hours, which would give us 0.1 hours. So 6 minutes is 0.1 hours. So we take the 16 hours originally, plus we add it to 0.1. Therefore, in total, it took 16.1 hours. And now if we highlight these two important informations, we've got the distance is 6,320.5 and the time taken is 16.1 hours. So speed is equal to distance over time. So therefore, speed is equal to 6,320.5 kilometers divided by 16.1 hours. And if you put this into your calculator, you should be getting an answer of 392.577 ... And remember, in IGCSE maths, you need to round off to 3 significant figures. So therefore, the speed is 393 kilometers per hour. We round up. So that gives us our final answer of the overall average speed being 393 kilometers per hour. So now all that's left, put this into the answer box. And there we are done. So as you can see, the problem, the 11 marker, it may look difficult at first because of the number of marks it is. But remember to, in your exams, remember to split up these big problems into smaller sub-problems. So as you can see, I first split it up into total distance and then total time. And then I split that even further into calculating the distances of each individual case. And then the overall time taken. So remember to, in your exams, split up these large problems into smaller sub-problems. And that will really help you tackle all the problems, especially those ones in paper 4. So yeah, that's it. That's all for this 11 marker. And if this video was helpful, please like, share, subscribe. And if you have any final questions you want to ask me before your IGCSE maths exams, please feel free to drop them in the comments and I'll get back to you as soon as possible. Thank you very much, and I hope this video was helpful.